So I came to Decodable with a background in data engineering, kind of like building out data warehouses and kind of like populating them and building aggregates and working with databases and SQL. So that's kind of like my background to it. And I spent a bit of time with Kafka and Kafka Connect and things like that. And I thought, this is cool. So Decodable, they have a managed Flink offering, and I'm going to learn Flink SQL. Like, that sounds cool. I get to do like stream processing. So I'm a data engineer, I know things about databases, like how difficult can it be? It turns out it's not entirely straightforward. Like Flink SQL sounds good. Like it's SQL, and if you know databases, then like that should make a lot of sense. But it turns out not entirely. There's like a fair few things that you're going to come across. So who's used Flink SQL? A handful? Who's never ever seen this message? Yeah. So like, as you start using Flink SQL, you find out fairly quickly that it has its own special love language that it uses to the user. It kind of like has different ways of saying that it's not happy doing something. And that's because it's built around Java, and Java has these kind of quirks. Now, I'll hold my hand up. As I said in the intro, I know how to build data warehouses, I know how to do data engineering, I know nothing about Java. Or rather, I now know a little bit about Java. So this talk is about like how much Java stuff, I'm going to wave my hands quite a lot, how much Java stuff do you actually need to be able to use Flink SQL and run it for yourself and understand like when it says no in its own little special way, when it says no, like how do we go fixing that? So we're going to take a look at how we can troubleshoot things, how we can find out what's gone wrong, how we can find out where things have gone wrong. And I want to kind of take you through some of the problems that I found and how I kind of found my way through them to hopefully equip you to be able to do the same when you're using Flink SQL. So let's think about troubleshooting to start with. Now, when it comes to troubleshooting Flink SQL, it's not a lot different to troubleshooting other things with computer systems. We need to avoid this temptation to like randomly try stuff. I've got an error, I take the error, I put it into Google, I see what the first thing is. That's not a great way to do things. Because if it works, we don't really know why it worked. It's like result one in Google doesn't always work. Maybe it did, maybe it won't. So we want to avoid this thing. And there's this great quotation from Linus Torvalds, "Now I will jiggle things randomly until they unbreak." And like he was like flaming someone on a mailing list for like how they'd coded something or they'd approached coding something. But I love this quotation for when we think about troubleshooting. Like, when you come up against an error from something, whether it's Flink SQL or any other thing, we need to understand, like, why did it happen? Where did it come from? And think through how can we fix it? And not just randomly jiggle things until they unbreak. So we're going to work out what's the actual error that Flink SQL's telling us, because it's not always entirely self-evident what the actual error is. Sometimes like something seems to work, but it didn't. Sometimes you get an error, but it's actually a different error that was at the root of it. Where's that error coming from? Is it coming from the thing that gave you the error? Is it coming from somewhere else down the line? So we're going to look at the components within Flink and within Flink SQL. We also need to think about, is what we're wanting to do even supported? Like Flink's a platform, we can add various different things into it, support for different technologies. Now some of these things don't actually support what we might want to do. Like there's an open table format and let's use that and we can write to it, but we can't update it because it's not supported yet. Like this is the joy of like piecing different things together. We're also going to look at making sure that things like versions line up. Make sure that we've got dependencies in place. Like we're going to talk a lot about jar files. It's in the title of this talk. And those things also need to be in place for actually making Flink SQL do what we want it to. Within Flink itself, there are different components. So we need to understand what's actually running where. Now, Flink's a distributed system, which is brilliant because it means that it scales really well. It means that it's fault tolerant and does all these lovely things. But it also means the components we're working with, there's not just like a single executable that either it's working or it's not, and a single log file that's either going to like have something in or it's not. There's a bunch of different pieces going on that might be on your laptop when you're running it locally. It might be spread across different bits of hardware or pods or VMs or like however you're running those pieces. We've got the SQL client. So we get our lovely ANSI, our squirrel, when you fire up Flink SQL and you can type in your SQL commands. And this is responsible for creating the jobs that Flink's going to run. There are other ways of creating jobs for Flink, but this is about Flink SQL, so I'm going to talk about the Flink SQL client. It sends those jobs to a process that's got a very cunning name called a job manager. So the job manager takes those jobs, it passes them on to another component, but the job manager also gives us a nice web dashboard, which we'll talk about in a moment. So that's really useful. So that's run by the job manager. But the job manager is responsible for taking jobs and then allocating that out to the available task managers. And the task managers are the pieces that actually do the work. So the job manager kind of like says, you can do this bit, you can do this bit, but the task managers, they're doing the actual graft. So you can scale your task managers for capacity and throughput. So like, let's have lots of these because we need additional processing power. Job manager keeps track of which ones are running and what capacity is there and allocates the work out to them. That's the components at a very high level. Okay, there's a link down here that's super small, but obviously I'm going to share the slides afterwards, and you can go look it up. Within the Flink documentation, there's more detailed diagrams. A lot of this talk is going to be about like just enough knowledge to know to get by. So I'm not trying to say like that's Flink's architecture. Like this is like the top level view, and then you can dig down into each of those pieces. But for what I've found, like that's enough of a mental model to have to start with. But go look at the Flink docs. They've got kind of like more detailed within them. I'm sure there's a bunch of talks at Current this year and Kafka Summit London and stuff where people also go into a lot more detail. But understanding where stuff runs is only part of it. We also need to understand what went wrong, because there are different ways in which things can go wrong. And it's not even always obvious what actually went wrong. It might be quite obvious. It might be, go create a database, computer says no. Okay, so Flink's like, I'm not going to create this database because of this error. And we'll talk about understanding that error later on. Sometimes, though, it's a bit more subtle. You say, I would like to go and insert some values into a table, and Flink says, okay, yeah, Flink SQL says, yeah, this is good, I've done that. And you think, okay, great. And then you go and query the table, and there's no data. And you're like, well, but it said the insert ran, so why is there no data? And this one took me a little bit to understand, but what it does in Flink SQL, if I can get my cursor thing to work, is it working? There it is. It says, I've submitted the statement to the cluster, it's been successfully submitted. It's been successfully submitted. It's not been run, it's been successfully submitted. It's asynchronous. So SQL client says, yep, I've sent that over and it's been successfully submitted. And the user thinks, I got a big double thumbs up. It says it's been successfully sent to the cluster, like it must have worked. But why have I got no data? So we then need to go and find out, well, did it actually work? And so we can do show jobs from within Flink SQL, and it'll say, well, one of them worked, one of them didn't. Your insert into, it says it failed. We can also go to the Flink dashboard that I mentioned. The job manager serves up, and that again shows us like what's running. It shows us the jobs that have worked, the jobs that haven't, and you can drill into them. Like a particular job, like did it work or not? Where did it fail? I find this view also very useful for starting to learn a little bit about how Flink does stuff. Like again, from an idiot's point of view of like, I'm going to observe this thing and see what it does. And like, oh, I've got like 3 different boxes. So I can see that Flink like splits up this workload and it's got a thing here and it's got a committer there. And you start to get an appreciation of what's going on. You could go back and read the design documents and like understand it from the bottom up. This is like from the top down, just like inferring things. But you get to see things like some metrics and how many bytes move around. So this is quite a useful thing in the Flink dashboard. So we know that something didn't work. We either got a straight up error from the SQL client, or we got the task manager showing like, no, I'm not going to do that, and it's failed for some reason. Why did the job fail? What does the actual error mean that we got from the Flink SQL client? For that, we need the log. Okay, the truth is the log. We find those in the log folder. So the Flink distribution, I'm using Flink 1.20 there. Underneath that, you've got a log folder. Underneath that, you've got a bunch of log files. The log files have got names. The names aren't entirely sensible to my reading. The SQL client one, yes, that's sensible. That makes a bunch of sense. That's the log file for the SQL client. The next two, though, standalone session and task executor. So, I mean, the job manager log file, you'd think you'd like the SQL client one's called SQL client.log. The job manager log, should we call it the job manager log? No, because we'll call it the standalone session log, because that makes things fun, yeah? The task manager log. Should we call it the task manager log? No. We'll call it the task executor log. So this is one of those things, the little bit of things that we need to know. We need to like raise our baseline of understanding of things to be able to get Flink SQL to do what we want it to do. So we've got our log files, and we can go and look at our log files, and we can find out the SQL client, it was doing this, and it threw this error. We can go over to the task manager and find the log file and say, okay, here it is, and it's trying to run an insert into, and then it throws this particular error. So the log file tells us like, the failure. That's not always enough, though. Sometimes we need to find out more information. And so we can configure the log files. We can say, actually, when you write information down to it, I would like more details. So it uses log4j2, and we can say, when you write any log messages, go write them at trace level. In 1.19 and above, this is part of the Flink configuration. So you just set that there, and it applies to all of the different log files, so your SQL clients and your job manager and your task manager. Below 1.19, you actually need to go and configure log4j directly. And there's different log4j configuration files. So the SQL CLI has got its own configuration file for log4j, and then job manager and task manager have got their own configuration files for log4j. Setting it to trace for everything guarantees you're going to get a deluge of information that you're going to struggle to find your way through, because it's extremely noisy when it starts logging everything at trace. That's like, tell me about everything. So what we probably want to do is we want to focus that down. We want to say, like, I reckon based on the error or based on what I've been poking around with, the error lies somewhere within what's going on with, I don't know, connecting to S3 or doing something with a catalog. So we can create these loggers. So we've got this thing over here, which isn't going to work. Bloody, there we go. It's not going to work. So you can create a logger. So you say, I'm going to give it a name, and we're going to target a particular component within what's going on, like the catalog, and what level do we want to trace it at. So by doing this, we can actually really focus what we're looking at within the log files. So rather than setting it all to trace and being like swamped in information that kind of makes it all useless, we'd probably set the root logger to like info, which is, I think, what the default is, and then we'd start focusing down particular areas to write log files at more detail. As well as saying write more detail, like when this particular component runs, like write it all at trace, we can capture different information when something does write a log. So we can say, instead of writing it in this thing called pattern layout, which is the default, say write it out in JSON, which is kind of bulky, but is useful because it gives you all of the payload that there is associated with the log messages. And then you can take that JSON and you can like run it through JQ or something to parse it further. So you've got that option there, change the format of the log that it writes. But this pattern layout is the default, and we can also customize that. So here's an example of where I had to do that. And a lot of the stuff in this talk is equipping you with the idea of how to go about troubleshooting certain things when certain things happen. So what I'm going to show you here is like, this is not like your bread and butter of like, I've taken the shrink wrap off of Flink SQL and I'm running it and I'm going to have to go and do this. They're like, most of the time you won't have to do that. But this kind of thing is useful to know exists, so that if you come up against certain errors, then you've got that knowledge of where to go and look for it. So what I was doing was I was trying to get Flink SQL to write to Delta Lake. Delta Lake, it's an open table format, and I was writing it onto an S3 compatible system called MinIO. So you've got S3 that Amazon provide, and it's kind of like it just lives up in the cloud. MinIO is something that you can run for yourself. It supports the S3 protocol, and it's got its own endpoint. So when we're using Flink SQL, we need to say, like, it's S3, like you can call it S3, but it's got its own endpoint. And I'd set the configuration, and part of it was working, and part of it wasn't. So I was seeing this really weird thing in the log messages. So this is at debug level. So I was already kind of like into the weeds a little bit, and like would set it to debug, and I would see this. At first it would say, I'm just using the default endpoint. So that second line down, default endpoint, don't need to do anything else. And then almost straight after that, it said, okay, yeah, I've got a custom endpoint. I was like, well, what's going on here? Because I've set the configuration, so either you've got it or you haven't. It's like Jekyll and Hyde. How can you have the configuration but not have the configuration? But that's exactly what the log messages were saying. It was saying, okay, I'm just going to use the default endpoint. No, I'm going to use a custom endpoint. And that meant that when Flink tried to write to Delta Lake, I got all sorts of errors. And it just like, no, I'm not going to do it. I had a bit of a theory that what was going on was something to do with the jar files, which we'll get onto at some point. And I was thinking, like, is it using different files? But like, how could it use different files? And this is me like grasping at I know computers do stuff, and I know that kind of things kind of like run within a process, but I don't know Java, so I can't actually troubleshoot this properly. But I'm going to kind of like narrow things down into like a broad area of where I think things might be going. So I had a theory that within the task manager that was trying to write out to Delta Lake, or to S3 rather, there were two different threads running. One was doing something and it was picking up the configuration. Okay, that's a second one there. One of them was doing something and wasn't picking it up. So I was like, can we actually find out what's going on? So within the log4j configuration, you can set this thing here. You can add in things like thread ID and the thread name. So I added that, restarted things, and I got this, which made me very happy because it gave me the evidence, not that I knew exactly why it wasn't working, but it confirmed that like there was something weird going on, and it was something to do with like one bit of the thing was happy reading the configuration, another bit of it wasn't. So that top bit there, thread ID 79, whatever it wasn't reading the configuration, thread ID 80 was. Now the real head scratcher was, this is all within the task manager. It's all reading the same configuration files, it's all using the same dependencies. What happened was, like, one of them was using a weird dependency that expected the configuration in a different way. So you actually had to like give the configuration twice with different prefixes, and then it was happy. So there's a blog about this on the Decodable website if you want to really get into the guts of it. The point being, less about Delta Lake, more about the log files sometimes give you that additional information. So you can configure them to give you that. We've looked at what components there are. We've looked at like where to go to find out what your error is and how to customize those log files to drill down into it if you need to. The next thing we want to talk about are some of the tools that we're going to use for inspecting what's going on within our Java process. So yet again, disclaimer, I'm not a Java person. Like, you Java people in the audience can come and heckle me afterwards and tell me what stuff I'm telling wrong. But for me, like, I know how to do databases, I know how to like do stuff with Linux servers. So I know I've got some Java processes running. So like, how do I find out which ones there are? Well, I do a ps -ef, and I grep it for Java. ps -ef, show me the processes, filter it for anything which matches Java. But actually, there's a Java tool that does that. JPS tells you the Java processes. So we do JPS, and it says, there's your Flink cluster. You've got your SQL client, you've got your standalone session, which is job manager, and we've got the task manager. Okay, so that's useful. What Java processes are running? JPS. What about those processes that are running? Like, can we find out any more information about them? Like, what can we inspect in them? We can use JInfo. So we know that SQL client's process ID 84163, but like, can we find out any more information about SQL clients? JInfo, or we can use pgrep and then kind of like get the process ID dynamically. And then JInfo spits out all of this useful information. We've got the system properties, we've got the VM flags, VM arguments. We've got things like the Java class path. So we can start filtering the output of JInfo to drill down into the bits of information. So again, just like digging into log files, that's not like your day-to-day bread and butter. But if you've got a process that you think you've configured in a certain way and you think should be starting up with a certain set of arguments or certain parameters or certain dependencies, you think it is, but is it actually? Well, you can go and inspect it. JInfo tells you about that specific process, about the class path that it's picked up, about the arguments that are there, and the flags, and so on. So JInfo is very useful. Other troubleshooting tools, bearing in mind that Flink's a distributed system, is looking at the network traffic that's going on. So Wireshark is like a really popular free tool, and you can use this to look at what's going on. So you'll notice there the source and destination 127.0.0.1, it's my laptop. It's all running locally. It's running locally, but the processes still talk to each other using the network. There's also T-Shark, so a CLI-based version of Wireshark. And you can attach this, you can just run it like, look at the local interface. You can also attach T-Shark to your Docker networks or your Docker containers. So you can run your Flink setup under like Docker Compose, and then you can actually look at the different bits of traffic going between the containers. So here's an example of like the Flink SQL client at the top. We run a command, T-Shark picks up that command, and we see it sending like a REST call. And we'll talk about why it's a REST call later on. But now's the time to grasp the nettle, which is this. Why are we getting a class not found exception? And that's because Flink SQL is a platform, or Flink rather is a platform. The distribution of Flink it gives us like our SQL clients and our task managers and a few little dependencies to get us started. So you want to read a JSON file or write a CSV file, it's good, it's got you covered. But as soon as we start branching out into things, we realize that Flink doesn't come pre-built with things to connect to Kafka, or to write Parquet files, or to connect to a Hive Metastore. For that, we need dependencies. And dependencies are jar files. Okay, so we're 21 minutes in, and we finally got to the point of the talk, which is the joy of jars. So a jar file is a Java archive file. Java archive, AR, jar is a jar file. And within that, you have these actual classes that it's going on about. Class not found exception. The class is something to do with Java. It's the dependency that we need. And these sit within jar files. So a jar file, it's an archive. It's like a zip file. You can actually unpack it and go and look at it if you want to. But these jar files are what we need to satisfy the dependencies. So let's say we want to write a Parquet file from Flink. We need to get the dependency for Parquet. The Flink documentation does tell us usually which dependencies we need. It's sometimes a little bit fiddly to pick its way through. Other third-party systems don't always tell you exactly the set of jars, or it's maybe out of date, but generally you can find that information in the documentation. But what's really, really important is that we pay attention to the jar file itself, because there's a very, very specific and logical way of naming jar files. So whereas, like at the beginning of the talk, I showed you all those different Java errors, and I was like, ha, 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 isn't this unintelligible? It's just a bunch of like word salad. The naming of jar files at first, to me, looked like that. I was like, yeah, it's like Flink Parquet something.jar. Let's chuck it in and see if it works. But that's the worst thing to do. That's randomly jiggling things, and things generally stay broken. They don't unbreak when you do that. Because the jar file has got a name. It's based on the package name. So like in this case, Flink Parquet. Then it's got the version of Scala, which was compiled. This bit, handwave, it's like 2.12 always seems to work for me. The next bit, though, super important. This is the version of Flink for which that jar file is intended. This is obviously quite an old one. 1.14 is relatively old for Flink. But you need to make sure that version matches up with the version of Flink that you're running. Now, I know what you're like. You're like, well, I've got this error and I just need this damn thing to work. I'll just use that. Like, I'm on Flink.115. Like, it's close enough. It's close enough. Like, it's only like one digit away. So like, we'll just try that. And it might even work a little bit. It might work entirely. It might not work at all. It might seem to work, and then you get some more weird errors. It's just not worth it. Like, unless it's been clearly documented that like this particular jar works with these sets of versions, then like, okay, that's fine. But generally, you need to line it up exactly. We also have different jars for connecting to other systems. So like we want to connect to the Hive Metastore. This one, Flink-SQL-connector-Hive, that's your package name. Then we've got the version of Hive. So depending on the version of Hive, we need a different version of the jar file. Then we've got our 2.12, and then we've got the version of Flink. 1.18.1, it's a bit of a more recent one, but that's the jar file that you need to get Flink 1.18.1 to work with Hive 3.1.3. Where do we get our jar files from? We go off to the internet, we go to Maven Central or Maven Repository, and we find it there. So in this case, it's the Parquet one. We type in like Flink and Parquet, and it finds our way to this. We make sure that we get the specific version. So in this case, 1.18.1. And then we look at the page, a little bit puzzled, because we're not Java people, I'm not a Java person, and there's group IDs and dependencies and artifact IDs and like what the heck IDs. But over here, in the center of the page, that little three-letter word, jar, that's the thing that you go click on to get the URL for the jar or like download it directly. So you've downloaded the jar. What do you do with it? I'll tell you what you can do with most jars. But this jar that we've downloaded, we're going to go and put in the lib folder of Flink. So Flink has got its distribution. You've got like bin, you've got log, which we talked about. You've got lib. So lib is where the jar files live. You can stick them all in the root of the lib folder if you want. You can also create subfolders, and it will iterate through them. So that's useful. Like in this case, I've called it ext because it's an external jar. But you can also create subfolders, for example, for the different systems. So like we're trying to connect to Kafka, so I'm going to create a Kafka folder, which is going to have all of the necessary jars for Kafka. Or we're trying to connect to Iceberg, that's going to have a set of jars there. And it makes it easier to reproduce your different environments. Or to work out like, I want to take this thing and run it over here. Which jars do we need? Well, if you stuck them all in the lib folder, then you end up copying across all of these different ones, and you end up with like versions conflicting and stuff. So putting them in subfolders is a useful way to do it. How do we know which jar files Flink SQL is going to pick up? Well, I've told you, it's in the lib folder, but how do we actually know? We can go and look in the bin folder when we run Flink and we do like start cluster or SQL client, and there's a set of different shell script files which all kind of like talk to each other, and there's a routine called construct Flink class path, which constructs the Flink class path. And it goes through the lib folder, and it iterates through it, and it builds up all the list of jars, and it passes this class path argument, which is a thing in Java land. The class path tells Java, here's where to go and look for your dependencies. So when you're running this thing and the user says they want to do Parquet or talk to Hive, you find that dependency to do that thing on this place, this class path. The other bit that we need to bear in mind when it comes to dependencies is this thing, Hadoop. Who remembers Hadoop? Like it was a thing, wasn't it? Like everyone got really excited by big data and all that kind of stuff. And Flink's like it's a mature project, and it kind of dates back to when Hadoop was a thing. And all of these, it was just like assumed that you had a Hadoop distribution, because who wouldn't? Like you've not got a Hadoop distribution on your machine. Like what's going on? So Flink, certain Flink things like Parquet, like Hive and stuff like that, they assume that you've got Hadoop and they need some of the dependencies from it. So when you run Flink, you either need to export the Hadoop class path, and it's a special environment variable that when Flink starts up, we'll go and pull its jar files from, or you just cherry pick out the jars that you need from a Hadoop distribution and dump them into your local Flink. Cherry picking is fine, but it's also trial and error. It's literally like, here's the class not found exception, okay, we'll add that jar file. Here's the next one, okay, we'll add that jar file. So it's tedious, but you end up with a much smaller footprint of your different jars. The last bit to do when adding a jar is to restart. Okay, like the number of times in which I've remembered to restart one, but not the other, like I've lost count of those. But make sure that you restart all of the different components, that you put the jars in all of the different lib folders if you've actually got different servers or VMs running your Flink components. Within a jar file are the bits of Java stuff. Like I mentioned this earlier, so it's a Java archive, we've got our class files. It's useful to be able to go and check it when we start debugging things further. So what I showed you before there, that's like your bread and butter of running Flink SQL. We need to add a dependency. You find the jar file, you download it, you stick it in the lib folder, you restart, and off you go. That's your day-to-day operation. But when things go wrong, and you still get a class not found exception, then you need to start digging into it a bit. So within the jar file, you've got the different classes. So jar is our command line tool. T tells us to get the contents. F says we're going to give it a file name. So this gives us a list of all the different class files within that particular jar. And we can start to then match up the class name that Flink SQL says that it can't find with the class name that's in here, and hopefully the things marry up. It's also useful to understand when our Flink process is running, where's it actually loading different things from. So again, this is on the troubleshooting side of things. This is not in the day-to-day stuff, but being able to look at that, so you start your Flink process with an environment variable, which is like a debug flag, which says, tell us where your individual classes are being loaded from. So again, once you start really digging into stuff and trying to trace down why is this thing not working and it should do and it's not reading configuration, where's it picking stuff up from, that can give you that information. But again, this is like the log stuff that we talked about. This is useful to have in your back pocket to know you don't need to be doing this all the time. I told you earlier about the different components within Flink. I told you that you've got a SQL client and a job manager and a task manager, and I kind of said that's your high-level view, that's all you need to know. But it's not necessarily as simple as that. It does get a little bit more complicated. So our SQL client is actually made up of two different processes. So when we do our JPS, and we see the SQL client process running, within that there's actually two things. There's the CLI client, and there's a SQL gateway, so an embedded SQL gateway. You can run the SQL client and the SQL gateway separately if you want to. That's a command line argument. But when you just do like .bin/SQL client.sh, this is what you get. You get an embedded SQL gateway. That's useful to know because if you start poking around the network traffic, if you start looking at log files, you'll see this. Within the SQL client log file, we've got a REST endpoint, and it's listing on this thing. And we type in a command into the SQL client, and it says, OK, I'm going to send a request to that endpoint. So we've got REST traffic bouncing around within the cluster. We can validate that using T-Shark. So you can actually see when I type this thing into the SQL client, what's actually going to send to the REST endpoint. So that's part of what's useful to know. The other bit that's really relevant is when we start talking to external systems. And this is where things get like a little bit hairy. So we've got our SQL client, we've got our job manager, we've got our task managers. Within the SQL client, we've got our embedded gateway. There's a bunch of other stuff, okay? Other stuff being the technical term. There's a bunch of other stuff that Flink's going to talk to. You've got catalogs like the Hive Metastore, or wherever you're storing your catalog metadata. You've got sources, you've got sinks, you've got Postgres, you've got Kafka, you've got wherever you're putting data, getting it from and writing it to. So the example that I want to show you is something that I did get working, and there's a blog about it, but it took me a bit of head scratching. Taking data from Kafka, writing it in Iceberg format to an S3 compatible store, and using the Hive Metastore for our catalog metadata. So the data itself shifting around is relatively obvious. Task Manager is going to pull the data in from our Kafka topics, and it's going to write it down to min.io, which is our S3 compatible system, using the Iceberg format. So it's another open table format. But what about the Hive Metastore? What about catalog data? What's actually going on within that picture there? Because this is what happens. We say, go create a catalog, and it says, yes, I can do that. Go and use the catalog. Yes, I can do that. Go create a database. No, I can't do that. Oh, bummer. And so what's happening here is we're seeing the error that SQL client tells us is going on. There's a class not found exception. There's an S3A file system not found. But that's fine. We went to that really good talk at Current 2024. We heard this guy talking about jar files. We know what to do because it's a class not found exception. We can fix that, definitely. We know where we're at with that, right? We go find the jar file. We take the jar file. We go put it in the lib folder. We restart things, and everything works really well. So we're going to check, because we got that jar file, and over on our SQL client machine, we go check underneath the lib folder, under AWS, there's our jar file, our Hadoop AWS jar file. That gives us our S3A file system, and we know that because we can look within it. So we do our jar TF to go and look within that jar file for that particular class that Flink's telling us that it can't find, and it says, yeah, but it's there. There's that class. So we're like, but the class is there, it's in the jar file's in the lib folder. We've rebooted numerous times because sometimes the third reboot actually helps. What's going on? So let's go and have a look at the log file. And in the log file for the SQL client, we can see exactly what it's telling us. Trying to create a database, it fails to create a database. Why does it fail to create a database? Because the class not found. So at this point, for all my talk about troubleshooting things methodically and not randomly unjuggling things until they unbreak, I definitely randomly jiggle things because I was completely stumped. We've got our SQL client, and we're saying, go create this database, and the SQL client saying, no, I can't find the class. And we're thinking, yeah, but the class is there. I can guarantee the class is there, the jar file's there. What on earth's going on? So there's an Apache Flink Slack community. It's really good. I highly recommend it. And over on there, I was saying, like, here's what I'm trying to do. Here's the error I'm getting. Like, somebody help out. And somebody helped out. They said, well, within that log file that you've shared, you've got your file system not found, but underneath that, you've got something about Hive Metastore, and you've got something about thrift. And it's like, well, that's interesting. Because Hive Metastore uses thrift to talk to. So let's take our SQL client, and we've got our Hive Metastore, and let's see what's going on within the network. So we're going to use our T-Shark thing, and we're going to like sniff the local interface, and we're going to look at any thrift traffic that's going on. So we do a create database, and we see the thrift traffic for SQL client talking to the Hive Metastore, go create this database called DB01, and we're going to put it on this S3 path here. So that's been sent to the Hive Metastore. If we go and look at the Hive Metastore, in the log file, we see this. Go create database, failed to create database, class not found exception. And that gets a double thumbs up because that's the error that we were seeing in the SQL client. And we know what to do with that. And we can prove this out. So the Hive Metastore is saying can't find the particular class, and we see that on the thrift traffic. It actually reports back to the SQL client, I can't find this thing, and then the SQL client says, well, I can't find this thing. So what I was doing was I was seeing that bottom bit of the picture. In the SQL client, I was saying create database, and the SQL client was saying class not found exception. And so I was banging my head on a brick wall because I was thinking the SQL client's telling me it can't find this thing, whereas what's actually happening is the Hive Metastore is telling me it can't find this thing. So what do? We go find this thing. We get the jar file, we put it onto the Hive Metastore, and happy days, we can create a database. But why was Hive Metastore needing that thing in the first place? Like, I was just trying to create a database. Like, what's going on with that? The Hive Metastore, it holds metadata information about our catalog. We've said to the Metastore, go create this database. Surely that's like, it should just be doing that. Why does it need something to do with S3? And this thing gets onto Iceberg. So Iceberg, it's an open table format. And what that means is on the object store, Iceberg stores data files. So underneath the /data bit of the bucket, we've got a bunch of Parquet files holding the actual data. And then underneath the same table, there's a /metadata folder and a bunch of metadata files. Things about like the schema, things about like the snapshots, things about all the kind of stuff that Iceberg does. What that means is that you can take any other engine and point it at that table and you can start querying it. So you can write to your Iceberg tables from Flink and read it with Spark or Trino or whatever you want to do, which is really cool. So what's going on, I'm going to explain. And it's going to get a little bit like this. Because there's lots of different moving parts that what we can do is we can find out from the network traffic. So I showed you that simple example where we've got the SQL client is talking to Hive Metastore, but if we put T-Shark on our storage and our Metastore, we get to find out the full picture of what happens when you say create database. What happens when you say create table? So to start with, you create a catalog, and in Flink, catalog is just like a pointer within Flink to where the actual catalog metadata lives. So we say create catalog, and there's no network traffic yet. That's just saying it's a catalog, it's an Iceberg catalog, and we've got the metadata is held in Hive, and then the data itself is on S3 on this warehouse path. So we say create database, and this is what we saw happen before. Go create the database, and it says to Hive Metastore, go create that database. So 0.5 is our client, 0.2 is the Hive Metastore, go create the database, and then we see that next line there, 0.2 Metastore says to 0.9, I hope you're keeping up, which is min.io, go create that path on the object store. So when you do a create database from your SQL client, Hive Metastore says, well, it's Iceberg. Iceberg needs to have that kind of like the table set up for it within the bucket. So the Metastore is saying to the object store, go create that path. SQL client says, okay, I want to use that database. So it says, I need to find out information about that from the Metastore. So we can do a get database. And the Metastore says back to the SQL client, here's the information about this database. It lives on this particular path within S3, and there's a bunch of stuff which kind of goes off the side of the screen to about here. And then we say create a table. So SQL client says to the Metastore, go create this table, and it lives here, and it's this initial snapshot ID for Iceberg and all sorts of stuff like that. And then the SQL client goes to the object store, and it says go create that metadata, because Iceberg metadata lives on the object store. And then we also see the Metastore talk to the object store and check that the path's being created. I've nearly finished, I promise you. It does get more interesting. The SQL client we're going to do an insert into. So far, everything has been driven from the SQL client talking to other things. But insert into is where it changes. Because we do an insert into, SQL client pulls information from the metastore about it, the SQL client reads some metadata from the object store, and then it says, okay, now we need to go and get that work done somewhere else. So the SQL client talks to the job manager and says, I'm going to go and send that information to the job manager. The job manager sends it to the task manager, and the task manager says, okay, I've got this job to run. I'm going to go do this thing. So when a task manager runs some stuff, it goes to the metastore to find out information about the table. It says to the metastore, I need you to update some stuff because we've got a new snapshot ID because it's an Iceberg-y thing. Then it goes and it writes some data to the object store, and it writes more metadata. So that's the flow of the interactions between the different pieces. But seriously, it's like the end of day 2 at current, like everyone's bored, everyone's falling asleep. Why the hell are you dragging me through network traces? Well, because I found it out and I found it interesting and I'm stood on stage till I get to. But seriously, like why is that actually relevant? Because it's another tool in our toolbox. It's another tool for like most of the time it just works. Most of the time you get your jar files, you stick them in the lib folder, you restart and happy days. But when it doesn't, having a picture of like what's actually going on, like which pieces actually talk to which pieces need those dependencies, where's the network traffic going to be, where can we go and check for that network traffic happening? And that's why it's useful to know that kind of stuff. It also gives us a very clear idea of what runs where. So when we run DDL, it's running out of the SQL client. When we do our creates and our drops and our alters, when we do our DML, data manipulation language, it's running on the task manager. So again, mental models of like what work's happening where are we going to expect to find errors, where are we going to find these different things. The exception to the rule being a create table as select, because that's both. So the SQL client create table as select is going to run as an insert statement on the task manager. So that gives us the ability, it gives us the tools in our toolbox to go from this to this. Happy days, we can create a database and we can write Iceberg data. So I have 3 minutes left. I will summarize, and then you can ask me questions or wake up from your slumber. Troubleshoot methodically. Like, that's the #1 thing, whether you're working with Flink or anything in computing. Unless like there's some like weird random number generator that deliberately screws things up. Stuff happens for a reason with computers, and taking a methodical approach to it is super important. Not randomly jiggling things until they unbreak. Understand the architecture of Flink and the different pieces within it, and the broader ecosystem of what we're writing to, and the S3s and the catalog stores. Get your jar files right. Like Flink will tell you soon enough if you haven't done, but those dependencies are absolutely key. And get your toolbox ready. Know what things there are that you can do once things aren't quite working, and roll up your sleeves and start troubleshooting. I've written more about this on the Decodable blog, so if you kind of like this kind of stuff, if you want to learn more about catalogs, which are a thing in their own right, you can go and find that there. And with that, thank you very much for coming to the talk. I know it's nearly the end of the day, it's kind of like energy levels are low, but I hope that's been useful. I will put the slides online. I'm @armoff on Twitter, you can send me messages there. I will hang around here, I'll be down at the Decodable booth also. Thank you very much.